Good. So maybe I can start. Yeah. All right. So Kamailio configuration security. So Kamailio is, of course, really flexible. That's what makes it really great. But of course, this flexibility, this can create security problems, right? So we will be focusing here in this presentation on Kamailio configuration vulnerabilities that we saw on client engagements. So we do penetration testing, and we see all of these configurations sometimes. And then after that, we will focus on not just fixing, small things, but more long-term proactive security approach. Like Daniel said, I'm, of course, Sandro, known for having made your lives more interesting, I think, in terms of, having released SIP-Vicious. And at Enable Security, what we do is we focus on doing penetration testing and security consultancy, security testing of voice over IP and WebRTC systems. This is our focus area. We publish a newsletter every month that covers voice over IP and WebRTC security, of course, called RTC Sec newsletter. Everyone here should subscribe, so we can have a bit more subscribers. So, Kamailio configuration security. Now, the Kamailio installations out there that are doing anything, really valuable, they tend to be not behind some application firewall, network firewall, sure, but, they need to be exposed. They're not hidden in some internal network, right, for them to be useful. In fact, in most cases, they are the SIP firewall or the SIP security gateway. They have a very important role. They might be called an SBC, a session border controller. So they have a security function quite often, these Kamailio servers. So having a security function means that these Kamailio servers have a very critical role in many deployments. Kamailio is, of course, very flexible, and the Kamailio configuration is like a scripting language. It's not your typical configuration language. And of course, this flexibility, like I said, has critical security implications. What's, I think, important to keep in mind is that it shifts the security responsibility heavily towards the administrator. So it's not only the code, but it's also the administrator, how they configure it, that is really important in terms of security. And of course, when we talk about the real attack surface, Kamailio is definitely one of the most robust software out there. But it's also a bit of a misconception in some cases, because so much of the interesting stuff happens in the configuration itself. So we'll first look at some real-world Kamailio vulnerabilities that we have seen in our work with very quick demos, or just one demo and some examples. And then in the second part, I will focus this presentation to look beyond just patches, just security fixes of Kamailio configurations. Instead, we would like to take a more strategic approach to this challenge of, security solutions. And also present a proof of concept tool that we've been quietly developing. So when it comes to real-world findings, this is just a slide showing a quick snapshot of common issues that we encounter. I'm not going to dive into these so much, but we have some case studies soon. But the point is that the details often lie in the configuration. And what's interesting when you start talking about security exposure is that, the more features you have, of course, the greater the attack surface, the more likely you have a security vulnerability, or a few. And Kamailio supports many features through its modules. The most obvious modules that can easily introduce vulnerabilities are the SQL ops, the exec module, of course, the AVP ops, and any of the RPC modules if you're exposing that sort of functionality. So let's look at some specific case studies. So the first one is a classic SQL injection via AVP-DB query. In the case of our client, this got a very high rating, a critical rating. And the configuration is, of course, very simplified, right? But it essentially looked a bit like this. I don't know if you guys from the back can see, but if the diversion header exists, then it reads the diversion URI, and it uses it when constructing the SQL query over there after the like, which is actually problematic. And this would have led to full database access. We have a quick demo here. So first, let's see how the server behaves with a normal SIP request. We're using our tools, of course. And we just send a SIP message, and it responds with a 403. Why is that? Because next we look at the configuration. But yeah, this is how this particular Kamailio was configured, roughly speaking. Of course, we changed everything as much as we could so that the original configuration was much more complex, and there's no customer names. But if the diversion header is there, then it doesn't return a 403. It does something. It goes to the route diversion to tag prefix, which does what we showed before, roughly speaking. Yeah, the diversion URI is being fed to an AVP, and then you have the like query, and it passes, well, what is essentially malicious user input, potentially, to the SQL database by constructing the query. And now we're going to look at what we're sending to exploit this. So this is an options request in this particular case. And we can see the sleep, OK, fine. But the most important thing is the single quote there in the SIP URI. And we're just appending and comparing the version of the SQL server. And then if it matches, it does a sleep. And in this case, it did sleep for 2 seconds, even though I'm slower speaking. And it responded with a 201 because there was some sort of error. Now, SQL injection is usually an attack that is applied against web applications, but really any application that uses a SQL query that constructs SQL queries from user input could be problematic. And Kamailio, with some of the modules, allows this. Now, in terms of recommendations, of course, strict user input validation. So, before passing the URI, check if there are only certain characters, and if not, don't allow it. And also the use of the transforms, in this case, escape.common, which is what's recommended in the documentation, did address this security problem. Of course, I don't know of database modules that support parameterized queries in Kamailio, but that would be great. That would be a better solution. Next case study, the denial of service via DNS query. So a bit of background. So Kamailio is obviously asynchronous. That's what makes it one of the things that makes it so useful. But of course, there are blocking functions, and blocking functions that take attacker-controlled input can exhaust workers. The DNS query function from the IPOps module is such a blocking function. And if you pass, for example, the from domain, if it's going to be attacker controlled most of the times, if you pass that to DNS query, the attacker could force long timeouts, especially since the attacker can control the DNS server in most cases. So let's look at the configuration. So yeah, I mean, you have just a DNS query there being called, and in many cases, let's look at how the attack might happen. So, and we've seen this, of course, in practice, and we've done it. So, as an attacker or as a pen tester, you would register your NS record on a domain that you control. In this example, ns1.example.org becomes an NS record, and it points to a fake name server that does nothing, okay? Does not respond to DNS queries. You might have IP tables so that you, for sure, don't respond to anything, not even ICMP reset. However, then what the attacker does is you flood the target SIP server with invalid host names, FQDNs, in the form of, random 8 characters. You change them all the time, okay, with each request. .ns1.example.org, and in Kamailio you might see something like this, right? And the thing is, these non-existent FQDNs will take a long time to fail, and then a legitimate request comes, and it will time out as well. So no response is received for a long time, and this is what denial of service is about, right? So in terms of recommendations here, of course, the ideal would be to avoid using such functions with user input, user-controlled input. But in the cases where we saw this, this meant that the client would have had to rewrite their Kamailio configuration logic, which is not very nice. So, we're pragmatic people, and the way to address this in reality, in many cases, is to just push it as down as possible in the logic, the DNS query, as possible. So you might have it behind strong authentication. You might have it also, perhaps, under strict rate limiting, which would greatly address this. And of course, if you can do input validation, like really strong input validation, so only good domains, but what is good domains, right, if you're exposing your SIP server. So yeah, these are the sort of solutions for this. Anyway, next case study is the open relay and amplification. And we're talking about something like this. You might have a weak regular expression. You might have no checks at all. We've seen this. And then the SIP server gets exposed on the internet by mistake. We've seen this. It leads to toll fraud. So this is just an example. But yeah, this would match enable security, but not only, but also enable security.hex.fun, which is our domain as well in this case, but it will be a bit different. So yeah, this is very simplified, of course, and it would relay to unintended subdomains or attacker-crafted URIs. And this could lead to SIP amplification, denial of service, where your SIP server becomes complacent in flooding a victim IP address, which might not respond to SIP. So there would be SIP retransmissions 10 times. So your server might not be the only one who's attacking that particular IP. So there might be hundreds of them. And then, they cause denial of service, and your server is also helping. And this might also lead to toll fraud. If your SIP server is, say, on an allow list or whitelisted or IP authenticated with a third party, your SIP trunk, it might start sending SIP messages if an attacker abuses this vulnerability, and then makes calls to PSTN and so on and so forth. So this can be quite dangerous. And in fact, Ivan over there had blogged about this, had noticed this on his honeypot and blogged about it. We also, of course, contributed and we worked together on this. Because it's been abused in the wild. I don't know if it's still going, but yeah, it's definitely a problem out there. There are various SIP servers, most of them not Kamailios, but we've seen this in our work as well. Anyway, how to abuse this? A SIP message would look something like this, right? Nothing special. We're using options here, but if you're doing toll fraud, you're going to use invite. But yeah. How to address this? The vanilla configuration, of course, has a very good example, if not myself, but it's not always possible to just check if it's yourself. So you might need to have strong regular expressions, input validation, but you need to, before using T-relay, you need to actually validate where you're going to send the next hop. All right, so these are things that we saw in pen testing, black box tests. So in pen testing, you might have a black box penetration test, and you might have a white box. Black box is where you don't have access to anything. And black box tests often miss configuration issues, right? So attackers might gain internal knowledge. Maybe that internal knowledge gets leaked on GitHub, for example. Attackers have much more time than penetration testers. Most pen testers, they last a week or two. We take a bit longer usually, but yeah, in 3 weeks, you're not going to find everything if you're doing, or everything worth finding if you're doing just a black box pen test. So I think we need to take a different approach here. Proactive defense is key. We need to shift left. That's what everyone is talking about in cybersecurity. So taking the approach of manual configuration review and together with security testing could be really complementary. And the basic principles, right, in terms of best practices, in terms of security, is strict input validation. These are the classics, right, especially for pseudo variables that are used in the logic. Use allow lists instead of deny lists whenever possible, white lists over black lists. If you're doing regular expressions, keep them as simple as possible, and then carry them, of course. You end with a $sign and so on and so forth. And then if powerful functions, make sure that you check them out, how you're using them, especially things coming from the exec module, things coming from the SQL ops, AVP ops, and so on and so forth. All right. So in terms of tooling, what we've been doing lately is we've been trying to identify which sort of variables are actually have user input, or part of them is user input. We've then also been looking at the core configuration documentation and the code to understand which settings have security implications, and also analyzing the module functions for injection risks, especially. And injection is not the only vulnerability, but it's a good place to start from. And the idea is to document these things, but also to build a tool that does static analysis to check Kamailio configurations and highlight potential vulnerabilities. And we hope to also contribute in terms of documentation and updating the documentation with warnings. We already did that with the exec module. It was quite an obvious thing to do, but also examples as well, giving better examples. So here's a quick, very, very simple. So what you can see is, this is better than grep, right? So that's what's important here, is that you have tainting of, you have the user agent, so the variable being fed to the variable A, and this tool can actually look for for this sort of stuff. So if variable C is actually coming from the user agent, so the variable, and then you want to look for usage of AVBDP query, which can introduce this SQL injection vulnerability, then yeah, it can detect it. A bit more about this tool. So we're calling it KamaScan now. So it's based on tree-sitter, which allows you to define languages. And of course, we have our tooling to search through the tree, and then for now, it acts like a very flexible tool. Okay, so it's very much works in progress, but I'd like to hear some feedback about this approach and if it's interesting for other people, so that we see what to do next with it. So a bit more about security best practices. So in terms of module usage, avoid risky modules, like exec, of course. In fact, we blogged about that so that we give practical examples of how dangerous it is. We've seen many cases, not too many, but we've seen cases where people were using the exec module to do things like creation of files and so on. This avoid that. It's better to go for things that are specifically for creation of files or for editing of certain things, rather than using touch with the exec and so on and so forth. Right. In terms of documentation, templates, and examples. So the current examples in the MISC examples, Kamailio, are not really best security practices. I think we need a bit of a community effort there to update the documentation, perhaps to include some warnings and better examples that don't introduce security issues. Especially since we're AI and humans, we're both learning from these examples, right? So if we want, the tools that are being used to perhaps write new configuration files to not automatically introduce security issues, perhaps we should be writing good examples. All right, so we're at the conclusion. Before I give a recap, I'd like to thank my colleague Alfred. This presentation is as much mine as it is his. A lot of the things he contributed to. And of course, Daniel for organizing this, and the Kamailio World organizers for doing this conference. It's really a great opportunity to meet you all again. And our customers who keep it interesting for us. And anyone contributing to RTC security. There's not many, but there are a few in this room. So thank you very much. Key takeaways. Almost there. Yeah, so keep in mind that Kamailio security relies heavily on its configuration. It is very possible to configure it insecurely, as we see in our work. And I think education, secure examples, and updated documentations is one way. Tools would be really great to have. Tools are always useful, right? And penetration testing, of course, is focused on configuration, is very, very good when it comes to testing large configurations. What to do? Stay informed. There's the newsletter. That's what one way that we contribute to this. Review your configurations, test, and contribute to the knowledge, collective knowledge. So yeah, questions.
Thank you. Thank you, Sandro. And thank you for your work outside of this event, of course, helping the telecom and open source world in real-time communication to get better and secure. Now, Randy, maybe you want to come in front to get the main microphone, and Sandro will answer. You have something to put, or you like slides or not? Just discussion. Huh? Do you have slides?
No slides.
Oh, okay. Then it's easy.
It's audio only.
What do I do?
Then you can use that microphone. I was thinking maybe you switch the microphone.
Okay.
Okay, questions, sorry.
Yep.
Questions for
1, 2,
I think there
3
is a
questions.
question.
Everyone is afraid. Santiago?
Okay.
Okay, thanks a lot for your presentation, always great. I was going to ask you about one specific topic that you almost mentioned about the generative language models and this vibe coding, that there are a lot of production code that is starting to appear or a lot of things. Do you think that we need to get details over this generated code about security and things like that? Because security, I think that it's learning for our documentation. If that there is an increasing of insecurities related with this kind of programming.
I didn't understand the question, though.
The question is maybe, is AI and generated code some kind of problem for security?
Potentially, yes. However, it's also potentially a solution. So, it's a very long discussion to be had. I've seen, not in the case of Kamailio configurations, I have not seen any code being generated from LLMs yet. I mean, we've done it ourselves, but not from clients. However, I've seen this in the normal other code, PHP and so on, and people are complaining about it, but also people are, for example, configuring their cursor or whatever, giving it instructions to always do a security review after suggesting some code. So, it's not necessarily terrible, but if you're only teaching it on insecure configurations, I think it could introduce it. I'm sure it would introduce security problems.
Sounds like it's good to continue around the beer
For
after,
sure.
Or a wine.
For sure. It's a very long
because
conversation.
It's AI, security, it's discussion
this is
here.
something
Thank you,
else.
Sandro, again.
Thank you very much.
Delay.